Hello. Today we'll be talking about the intermediate value theorem, or IVT, which is a pretty short topic. It's not super complex, so this will be a short lecture today. Let's begin. I apologize in advance. Dude is not with us today. So I have this graph up here. We'll get into that later, right? So the IVT states that if function, let's say f of x, is continuous, and I'm just going to abbreviate that CONT dot, continuous, on an interval, closed interval with brackets, meaning including A and B, and let's say x. X is between f of A and f of B. IVT, which is the intermediate value theorem, guarantees that there is a C, like a value C, like remember from our limits video, a value C with, I'm going to abbreviate with W slash, f of C. Here, let me write this as a compound inequality rather. With f of A less than f of C, which is less than f of B. And I wrote that wrong again, sorry. It's less than f of B. So, let's go back up to this graph here that I have. F of x is a continuous function. We could see, I could draw this line without moving my pen at all. I should make an arrow there, right? Now, let's say A equals 3, right? And B equals 8 there, coming from our x value inputs. Now, because f of x is continuous, f of x is continuous on, and then that closed interval. I wrote a 5 there. 3 to 8, right? Now, f is continuous on that interval, and let's say we are trying to look for value, and I have written here x equals c and f of x equals 6.5, right? Now, we are asked a question. That question is, does the intermediate value theorem guarantee that 6.5 will show up between 4 and 7? Or x equals 3 and x equals 8. Now, if we think about this, if I were to draw a straight continuous line from x equals 3 to x equals 8, it'd look like this. Now, what the intermediate value theorem is saying is that if this is continuous, any graph between 3 and 8 is continuous, that you will pass all values between 4 and 7, the output values of those endpoints. Now, right, this continuous graph can look like whatever. The IVT is saying that because 6.5, which I've underlined here, is between the output values of our endpoints, 4 and 7, right? There exists a value, x equals c, right here, with f of c equal to 6.5. The intermediate value theorem guarantees this. Because this is continuous, and because 6.5 is between 4 and 7, there will be a value on this function, an input, that corresponds to an output equal to 6.5, because 6.5 is again between 4 and 7. So that's really all the intermediate value theorem is saying. Let's have another example. I'll show it down here. Let's say we have a graph of g of x and of x. Now, let's say that graph looks like this. So it's not continuous, right? Let's pick intervals 2 and 6 here. Now, in this case, the intermediate value theorem cannot say anything about this function because there is a discontinuity on our interval. Let's say our interval is 2 to 6, right? Because this function is not continuous, the IVT cannot guarantee that a value, let's say, let me use a different color here, 4 exists, right? Let's say this is 2, and let's say up here this is 6, right? IVT cannot guarantee that 4 exists because this function is not continuous, right? And now I'll erase this writing here. By the way, this writing is very important. It is the word definition of the intermediate value theorem. I'm going to go ahead and erase it though. Make sure you hit down that writing. That is the proof. Okay, so last example here. If we have a graph, right? Let's say this is 3, let's say this is 6, this is h of x, and x-axis, right? How do we say this? Let's say our function looks like this. Just a linear decreasing line, right? Now this is a continuous function on the interval 3 to 6, right? But let's say we're asking, let me give you some output values. Let's say this is 6 and this is 2, right? Now, question, does the IVT guarantee 8 exists on this continuous interval? The answer is no. Let's say 8 would be right here. The IVT does not guarantee that a function output of 8 exists. It could exist, like let me redraw this graph here. Let's say we start at 6 and end at 2. We could take a weird looking path like this. But, however, the IVT does not guarantee that 8 exists. Remember this straight line example I gave you? If you were to draw a straight line between 6 and 2, only these values, highlighted in blue, are guaranteed by the intermediate value theorem. So that's all I have today. I'll give you a quick look at these examples. All right, thank you for joining me. Goodbye, class.